Hello, my name is Sam Miller. Today I will be presenting on two key security tools, AppArmor, which controls what applications can do on Linux, and HTTPS, which secures traffic between clients and servers. So at both the operating system and network level, security controls are very important. So we're going to discuss a couple of tools that help out our servers, Ubuntu and Windows-wise. So first, we're going to look at AppArmor, which applies restrictions to processes on Linux. Then we are going to move on to HTTPS, which secures communication across the network. So the goal is to not only understand what each of these tools do, but also to know how to harden them in practice. And finally, to verify that they are configured properly. So an overview on AppArmor, we discussed this previously on our last presentation. So just a little recap, AppArmor enforces what is called a mandatory access control, or MAC for short, for each program. So instead of trusting an application to behave the way that it should, AppArmor applies a profile that defines what it is allowed to do specifically. So such as what files it can open or what network ports it can use. So it's just an extra level of security to make sure that we don't have anything that we don't want within our operating system. So normally Linux applications run with the permission of the account that they are under. It's inherited, but that can provide to be too broad and just in general create a security risk. So AppArmor can help reduce this by applying least privilege. So we give the account the least amount of privilege that it needs to run in a way that it should. So we don't want to give an account or user more privileges than that they can handle in case they use it for anything bad, or usually just accidentally use something that they shouldn't and inherently create a security risk. So to monitor users, there are two modes. One is enforce, which is aptly named. It just blocks and logs violations. And then there is complain mode, which only logs but lets the application still run. So kind of think of it kind of like a seatbelt for processes. The program can still run, but it can't go outside its safety range. So kind of like a safety net. So let's get into the technical side of things. So for AppArmor hardening, the first step is to confirm that it's actually active. There's no point in hardening something if it's not actually running. So we are going to run the AA status command, which shows how many profiles are loaded and how many of them are in force versus complain mode. So in case we want to upgrade something or downgrade something, we need to check to make sure all those profiles have the correct mode that is given to them. So from there, we can use the AA enforce to move services into enforce mode. For new services, AA genprof, which helps create profiles, and AA logprof, which refines them based on logged behavior. So it just adds another level of auditing so we can track the users and make sure everything is the way that it's supposed to. So it's also important to regularly check the logs for any denied messages, which shows which apps tried to step outside of their profile rules. So this confirms that AppArmor is actively protecting the services that it should. And also it's just another way to audit it a little more. So for HTTPS, HTTPS is a secured version of HTTP. It stands for Hypertext Transfer Protocol, and it's how web browsers and servers exchange information with each other. So by default, that's going to run on what is called port 80. The problem is that HTTP sends all data in plain text. So that means everything from usernames to passwords, cookies, sometimes even credit card information can be intercepted, and that's not something that we want. It leaves them vulnerable to sniffing, MTM attacks, and of course, credential theft. So HTTPS is HTTP plus TLS SSL encryption. So by that, it means it runs default on port 443, which means that the same web traffic is exchanged as it would be on HTTP, but it has an extra step. It is going to be inside an encrypted channel. So it's just a layer of security, which is what TLS stands for, Transport Layer Security, and SSL is Secure Sockets Layer. So SSL is a bit of an older standard version. TLS is more modern secure version. So we are going to use TLS for intents and purposes of making sure everything is secure as it can be. So when a client connects, TLS is going to negotiate that encrypted session before any HTTP data is exchanged. So again, it's making sure that that tunnel, that encrypted channel, is built the way that it should be before any data is shared with each other. So in cybersecurity, we all know the holy trinity of security, which is the CIA, confidentiality, integrity, and authentication. So for HTTPS, it kind of covers all three of that at once, which is, we love to see it. So attackers can't read the data, they can't modify it in transit, and clients know that they are actually connected to a real server. So they're making sure that they're talking to something that's real and not fake that can be intercepted. So let's get into the hardening side of HTTPS in IIS, which stands for Internet Information Services. So this is Microsoft's built-in web server for Windows Server. So many enterprises will use IIS to host websites and web apps, especially any ASP.NET applications. So for our lab, IIS is a required application for HTTPS on Windows Server 2022. To harden this, we are going to bind a certificate to the site on port 443 in the labs. A self-signed cert works, but in production you can use a trusted CA. Then we are going to disable older and secure protocols like SSL version 3 and TLS 1.1, 1.0. And enforce anything TLS 1.2 or higher. Again, it's more modern, more secure, so we want it. This is going to be done through the S channel settings on registry, or our favorite, the group policy. And then we are going to enable HSTS, which stands for HTTP Strict Transport Security, kind of a mouthful, so we're going to keep it as the acronym. So this ensures that browsers always use HTTPS and never downgrade, so none of the information is shared in plain text, again, which helps prevent any cookie hijacking, any packet sniffing and stuff like that. So to manage this, we need to rotate and manage certificates. We need to make sure that we're not going to be using any expired or unused certifications. Just keep things more up to date, more secure. We don't want to be running on old technology that has vulnerabilities and known exploits that can be used against our operating system. So now let's talk about Apache. So Apache HTTP server is one of the most widely used open source web servers in the world. This is kind of a pattern that we are going to notice within Ubuntu Linux, is that it's mostly open source things. It's flexible, it's modular, it's default on the Linux servers. Apache uses modules to add features like mod SSL for HTTPS and mod headers for security headers. As well as the previous slide, Apache is a required application for HTTPS on Ubuntu 24 for our labs. So to harden this application, we have to enable SSL and header modules with A2EN mod SSL and A2EN mod headers. Without these, Apache cannot process HTTPS or set security headers. So again, another level of security, we want to make sure that we're running on HTTPS. We don't want to enforce any HTTP. And then we are going to configure Apache to only allow TLS 1.2 and TLS 1.3 blocking older versions. So similar to what was done in IIS, we just don't want to be running on any old security that has any known exploits, anything that can be used against our operating system. So we're going to also ensure that we're using strong cipher suites like AES GCM or ChaCha20 to protect against any cryptographic attacks. We're also going to add the HSTS headers so browsers can always use HTTPS, again, to make sure that we're not forcing any HTTP traffic. And then we are also going to keep certificates up to date. So it's kind of like a copy and paste of IIS, just in a little bit of a different language. We don't want to be using any out of date, anything that, again, has known exploits. So we have to make sure that everything is running the way that it should be. So to verify that we are running the checks locally and externally for AppArmor, we would run a AA status, again, to confirm that the profiles are loaded and enforced. So it's kind of a two birds, one stone situation. For IIS, we would use netstat on the server to confirm it's listening to port 443, which is the secure version, the secure port. Then run nmap from the Kali lab machine to prove that the port is opened externally, just to make sure that's running right. And then for Apache, we would use SSTULPN on the server to confirm it's bound to port 443 as well. Then run nmap from Kali to validate it's reachable. So very similar. IIS and Apache have very similar hardening, confirmation, verification stuff. So to summarize what we talked over, since it was very technical, AppArmor restricts applications to least privileges, enforces profiles, and logs violations. So it's very flexible, easy to use in the sense that it's simple, but it is technical. It requires command line to run it properly. So you have to make sure that you are comfortable with the CLI. HTTP is a insecure plaintext, while HTTPS uses TLS SSL to encrypt traffic, which is done through port 443. And IIS hardening includes certificate binding, enforcing more modern TLS, and enabling HSTS and managing certificates. Apache hardening includes enabling SSL modules, enforcing a secure TLS, and using strong ciphers, adding HSTS, and keeping certs fresh. So again, Apache and IIS are hand in hand again with this. And finally, verifications must always include nmap from Kali as required by the server check assignment. So we want to make sure everything's running in accordance to the course, and making sure, it's running correctly, just a verification. For references, these are everything that I use to find the command lines, the tips and tricks and walkthroughs for how to harden the servers properly in the applications that we will be using. These references include Ubuntu documentation for AppArmor, Microsoft Learn for IIS and TLS, OWASP, and Mozilla resources for TLS, and manuals for SS, Nmap, and curl. So these are all the full and complete APA citations that were used through the entirety of this presentation. Thank you very much for listening to my talk, and I will see you guys again soon.